Hi everyone. Today we are going to learn about complex zeros. We're going to learn how can we find all solutions to a polynomial. With the fundamental theorem of algebra, we know that a polynomial has as many roots as its highest degree. That means if I have a polynomial like this one, this example, the degree of this polynomial is 3. It's the exponent of the term with the highest exponent. So 3 is the degree of this polynomial. That means it has 3 roots. Or this example, 2 times x to the power of 5 plus 2x to the 4 minus 3x. The term with the highest exponent is this one, so the degree of this polynomial is 5. That means it has 5 roots. But what happens when some of those roots don't show up on a graph? So let's figure this out. Let's look at this example. X squared plus 4. We want to graph this function. We know that the parent function is x squared, which is just a parabola. But this function has moved up 4 because we have plus 4 after the function. So in order to graph it, I'm going to use this parabola and move it from the 0 to 4 right here. So I move it up. So this will be the graph of my function. Now, let's answer the first question. How many roots does this quadratic equation have according to the fundamental theorem of algebra? Obviously, it has 2 roots because the degree of the function is 2. So basically, when I have a root in my function, I expect to see the root on my graph somewhere like this. Let me show you this example. Let's say I have a parabola like this, although it's not a really accurate parabola. However, the roots of this function are going to be here and here, where the function is meeting the x-axis. So this is what I normally expect. But on this function, I expect to have 2 roots, but I don't see any of them here because the function is not meeting the x-axis at any point. So when it says how many roots does the quadratic equation have according to the graph, I would say 0 because the graph is not crossing the x-axis. So basically, I expect the function to have 2 roots, but I don't see them on the graph. Now, let's see if we can find the roots algebraically. Obviously, we're going to set x squared plus 4 equal to 0, and then we subtract 4 from both sides. These two cancel, and x squared equal to negative 4. Now, take the square root of both sides. The power of 2 and a square root cancel each other, and x is left on the left side. On the right side, we're going to have plus and minus the square root of negative 4. However, we have learned before that if you have a square root, you cannot have a negative on the radical. If there is a negative, that means there is no solution here. So I couldn't find any roots on the graph, and also I couldn't find anything on the function when I solved it algebraically. How do I solve this problem? How do I find the zeros then? So let me introduce this word to you. Imaginary number, which is also called as I, is a number that is expressed in terms of the square root of a negative number, usually the square root of negative 1, and it's represented by I or J. So basically, I is equal to square root of negative 1. And obviously, when you multiply I by itself, it's going to be equal to negative 1. Because we have learned before, if you have the square root of, let's say, a times itself, so here I have I times I, that means square root of negative 1 times square root of negative 1. This is going to be equal to square root of a times a, and that's the square root of a squared. Now the square root and the power of 2 cancel each other, and it's going to be equal to a. So the same is happening here. When I multiply I by I, I'm multiplying square root of negative 1 by itself. So obviously the answer is going to be -1. So this is what we need to always remember, that I is equal to square root of -1 and I times I is equal to -1. Okay, so knowing this, let's go here. Over here, when we're trying to solve this equation, we figured out that x is equal to plus and minus the square root of -4. We can rewrite the square root of -4 as square root of -1 times the square root of 4, because -4 is basically -1 times 4. I can write that here for you as well. See, -4 is square root of -1 times 4. Now I can separate the radicals. So I can write -1 times 4. Square root of -1 times the square root of -4. So basically, I was able to rewrite this part of my equation that I solved as x equal to plus and minus the square root of -1 times the square root of 4. And guess what? We just said that I is equal to square root of -1. So wherever I see square root of -1, I replace that with I. And we know that the square root of 4 is also 2. So I just can write x equal to plus and minus I times 2, which we can rewrite it as plus and minus 2i because we are used to write the numbers before the letters. So the solutions of this function are now appeared here as plus and minus 2i. The solutions are imaginary numbers because we were not able to see them on the graph, so we called and we use this imaginary number I, so the solution is also an imaginary number. So this was one example. Now let's work on this one. So here we want to find the solution of this function, x squared plus 2x plus 5. We have learned the quadratic formula before in Algebra 2. Quadratic formula says in order to find the root of a quadratic function, you can use this formula, x equal to -b plus and minus square root of b squared minus 4ac divided by 2a. What is a, b, and c? They are basically the coefficients of x squared. So this is a, which is 1 in this case. Coefficient of x, that's b, so it's 2. And the constant number is called c, which is 5 here. So I found my a, b, c, and I'm going to replace them here. Negative b will be -2 because b is 2 here. Plus and minus the square root of b squared. So that's 2 squared, which is 4. Minus 4, which I wrote 4 here, times a is 1, times c, which is 5. And divide by 2 times a. 2 times 1, which is just 2. Okay, now on the radical, 4 times 1 times 5 is -20. Then this is -20, so I'm going to write -20. 20 plus 4 is -16. So this is the answer that I get when I try to evaluate this expression. Is equal to -2 plus and minus square root of -16 divided by 2. Again, we see a negative on the radical, which is not acceptable in real numbers. So we're going to change this -16 as, so I'm going to write that here, -16 is -1 times 16. Now I separate the parentheses, I'm sorry, I'm going to separate the radical as the square root of -1 times the square root of 16. And we know that -1, square root of -1 is I. So this will be I times the square root of 16. So instead of this part, instead of square root of -16, I can write I root 16. And also we know that root 16 is 4, because 4 squared is equal to 16. So I can rewrite as -2 plus and minus 4i, because this is I times 4, and I can rewrite that as 4i. And in the denominator, I have 2. Now I can just simplify this expression. I can divide all these by 2. So 2 divided by 2 is 1, 4 divided by 2 is 2, and this 2 divided by 2 is 1, which I don't have to write that in the denominator. So these are my roots. I have 2 roots as I expected, because the degree of this function is 2, so I have 2 roots. One is -1 plus 2i, the other one is -1 minus 2i. So notice that we have 2 roots basically here. Okay. Now let's look at this parabola that we have here. It's a quadratic function basically that has 2 roots. Let's say one here at A and the other one here at point B. So I can rewrite the equation of this quadratic function using these 2 roots. I can write them as x minus A times x minus B. So if you have the roots, you can write the equation in the factored form this way. So here on the example that we just solved here, we had 2 roots, -1 plus 2i and -1 minus 2i. We're going to rewrite that in factored form. Basically, all we are going to do is to write the write the function using the same idea that I just talked about. So x minus the first root and x minus the second root. And then we're going to simplify them to distribute the negative. It's going to be +1 and -2i. And distribute this negative as well. It's going to be +1 and +2i. And that's it. This is the function in factored form. Now let's answer this question. Could a quadratic function have one real and one imaginary root? Explain why or why not. So the answer is no. When you solve with the radical, you always get a plus and minus I. So remember, we always have 2 imaginary roots, and they're like, because they come with plus and minus I, they are called conjugate of each other. So let's look at this example that we just solved here. We had 2 roots, -i plus 2i, -1 plus 2i, -1 minus 2i. We call them conjugate of each other because we have -1 plus, and the conjugate of this one will be -1 minus 2i. Okay, always have 2 complex zeros. Now, let's do one more example. We want to find all the roots of x squared minus x plus 4. Again, we're going to use the quadratic formula, which is x. I'm going to write that here for you. X equal to -b plus and minus square root of b squared minus 4ac divided by 2a. So here the a value is 1, b value is -1, and c is -4. So I'm going to write them, plug them into the equation. -b will be, because b is -1, negative of -1 will be +1, plus and minus b squared, that's -1 to the power of 2 is equal to 1. And -4 times a, which is 1, times c, which is 4. Now, 4 times 1 times 4 is -16. Negative 16 plus 1, negative 16 plus 1 will make negative 15. So on the radical, we have basically square root of negative 15. And again, we're going to separate that as square root of negative 1 times the square root of 15. This is I. So we're going to write 1 plus and minus I square root of 15 divided by 2. So this is representing the two roots of the function. The two roots are 1 plus I square root of 15 divided by 2, and the other root is 1 minus I square root of 15 divided by 2. Okay, now we're just going to practice a little bit working with imaginary numbers. We have two imaginary numbers here and we want to multiply them together. One of them is negative 2 minus 7i. Next one is negative 2 plus 7i. As we have learned before, we're just going to distribute them. Distribute the first one to the first term. Negative 2 times negative 2 is 4. Then negative 2 times 7i will be negative 14i. Next, we're going to go to the next term. Negative 7i times negative 2 will be positive 14i. Negative 7i plus 7i, times 7i will be negative 49i squared. So the negative 14i and positive 14i cancel each other. And we know that I squared equal to negative 1. So I replace that negative 1 here. It's going to be negative 49 times negative 1. That makes it positive 49. Because you know negative times negative is positive. Then we have only 4 plus 49, which is equal to 53. Now here's another example. We know that we have 6 plus I and 4 minus root 3. They are the roots of a fourth degree polynomial. Find the remaining roots. So we know that if we have a fourth degree polynomial, we expect to have 4 roots. We have only 2 of them. What are the other 2? They're going to be conjugate of these 2 roots. So here, if I have 6 plus I, the conjugate of that will be 6 minus I. So you just need to change the sign of the term that has I with it. So minus I. And this one also, if you have root 3, 4 minus root 3, conjugate of that is going to be 4 plus root 3. Again, conjugate of that, because you see, when you are solving with quadratic formula, we have negative b plus and minus the square root. So that's why we have a minus here and a plus here. So these are the other 2 roots. Now let's answer this question. If we know that I is equal to square root of negative 1, what is the sum of these two imaginary numbers? So notice this time we have plus between them. Over here, we were multiplying them, but this time we have plus between them. So we have learned before, if we want to add two algebraic expressions, all we need to do is find the like terms and combine the like terms together. So just imagine the I, just consider the I as a normal variable like X, Y, whatever you have seen before. Just treat the same as X with I. So here, I'm going to look at the terms here. 7 plus 3i minus 8 plus 9i. What are the like terms here? 7 and negative 8 are like each other because none of them have any variable. So just combine them. 7 and negative 8 is negative 1. And 3i and 9i, they both have I with them, so they are like terms. So combine them. 3 plus 9 is 12i. So that's the answer. Okay, so this was today's lesson. I hope it was very helpful for you all. Have a great day.